Now this is my question, RH criteria. This is my question. Diagram is given. Okay, diagram is given. G of S we have for the system, the characteristic equation we have to find out. Okay, diagram is given. This is G1 of S, this is G2 of S, and H of S equal to 1 because unity feedback system. H of S equal to 1. Okay, now G of S is nothing but G1 of S into G2 of S, which becomes K into S plus 1, and then S plus 3 divided by S into S plus 2. Okay, and this becomes K into S plus 1, S plus 3 divided by S into S plus 2. This is G of S alone. G of S alone. Already H of S is 1 because unity feedback system visible from the given diagram. Now I am going with closed loop transfer function, which is G of S by 1 plus G of S H of S. G of S by 1 plus G of S H of S. Okay. Now this becomes K into S plus 1 into S plus 3 whole divided by 1 plus, okay, S into 1 plus, or I will simplify this directly. I am simplifying this directly. I am simplifying this directly. When you put denominator and make LCM, we will get something like this. S into S plus 2, okay, plus K into S plus 1 into S plus 1 into S plus 3. I am substituting and simplifying, okay, both. Now, denominator of this closed loop transfer function is nothing but characteristic equation. This denominator is called characteristic equation, okay. So, which is nothing but CE, characteristic equation. Now, I will take that characteristic equation and simplify. So, the denominator is S into S plus 2 plus K into S plus 1 into S plus 3 equal to 0. Simplify this, S square plus 2S plus K into S square plus 4S plus 3. Is it okay? Equal to 0. Now all similar terms together, 1 plus K into S square, then 4K plus 2 into S plus 3K equal to 0. This is final equation, which is characteristic equation for the given question. Okay, this is one model, finding characteristic equation alone. Here you can see you have to find first characteristic equation, then apply RH table and tell about the stability of the system. Okay, I will complete this and come back to the previous problem. You can see in the first column of RH table, the elements are, okay, first column of RH table, elements are 5, 2, minus 0.1, 2, 1. Okay, now you must tell how many poles are on RHS, because denominator means poles only. Closed loop transfer function, you have numerator and denominator. Numerator will give zeros and denominator will give poles. They are asking how many poles are on RHS. Okay, number of sign changes equal to number of roots on RHS. So how many sign changes? This is positive to positive. Okay, this is RH table, first column alone, elements are given. Now positive to negative, so one sign change. Negative to positive, second sign change. Positive to positive, no sign change. So two sign changes are there. So two poles are on RHS, poles of closed loop transfer function. Okay, so denominator means characteristic equation. So those roots, now answer is 2. Number of roots on RHS equal to 2. Total roots, you can see if this is S power 0 row, S power 1, S power 2, S power 3, S power 4. Total roots are 4. Total roots are 4. We don't have complete table. We don't have complete table. System stability you can conclude because at least one root on RHS, system is unstable only. Okay. On LHS maybe remaining roots because we don't have row of zeros. Marginally stable roots on imaginary axis means compulsory row of zeros will come in RH table. Okay. System is definitely not marginally stable because root complete row of zeros is not present. System is not stable because at least one root is present on RHS. System is concluded as unstable. Okay, system is concluded as unstable. Now with this problem, I will close the class. Here G of S, H of S is given. What is closed loop transfer function? G of S divided by 1 plus g of s h of s. Okay. Now, if you simplify this, 1 by s plus 1 divided by 1 plus 1 by s plus 1 into k by s into s plus 2. Okay. Now, on simplification, this becomes 1 by s plus 1 into s plus 2 plus k. Now, denominator, we have to take characteristic equation. Characteristic equation is s plus 1 into s square plus 2s plus k equal to 0. Now, this becomes s cube plus 2s square, okay, plus s square plus 2s plus k equal to 0. So it becomes s cube plus 3s square plus 2s plus k equal to 0. This is our equation, characteristic equation. Now using this, we have to prepare RH table. Using this characteristic equation, we have to prepare RH table. So s power 3 is there, highest power, s square, s power 1, s power 0, okay. Now write the elements. Write the elements in the first two rows. Write the elements in the first two rows. S power 3 coefficient, S power 1 coefficient, it is 1 and 2. Next, S power 2 coefficient, S power 0 coefficient. Okay. Now we will proceed with further rows, values in the further row calculation. 3 into 2 minus 1 into k divided by 3. So it is 6 minus k by 3. No further calculation possible because previous rows no values are available. Now I am going with s power 0 row. How to calculate this fraction into k minus 0 into 3 divided by this fraction. The fraction will get cancelled, so k alone will remain. No further calculation. RH table is completed. Okay, RH table completed. Already in the given question, it is mentioned system is stable. It is mentioned system is stable. So which means all the first column elements are positive coefficients. Okay, all the first column coefficients are positive. All the first column coefficients are positive. Okay, because system is stable mentioned. So if that is so, k greater than 0 is one condition. 6 minus k by 3 also greater than 0, which means positive. So k greater than 0, we cannot further simplify. Next, 6 minus k is greater than 0 and k minus 6 is less than 0, k is less than 6. Okay, so we got k less than 6 and k greater than 0. Based on this, we can conclude 0 less than k less than 6. This is the range of k for system to be stable. Range of k for system to be stable. Okay. So out of the 4 options given A, B, C, D, the last option holds good. Answer is option D. Okay. So with this, I have completed basic RH table, how to calculate, and then stable, unstable, how to decide based on the first column, and then special cases, only first element 0, how to proceed, complete the RH table, and complete row of zeros come, how to proceed with the RH table. Okay.